distribution, and I asked the class, for purposes of posterity, to recalculate the binomial formula, specifically n equals 4, p equals 0.5, and the x values are from 0 to 4. And we know from the tree diagram the answer is 1 out of 16, because it heads was one among 16 possibilities. And plugging it into the binomial formula, again, you should be getting 1 out of 16, etc. Then I asked the class to actually have Excel simulate spinning 4 coins, or flipping 4 coins at 0, 1, 0, 1, 0, 1, 0, 1 by the rand between function, summing them, and Laura found 502 out of 8,000, which, if you think about it, 500 out of 8,000 is exactly 1 out of 16, I believe. And therefore, her answer theoretically, practically, is very close, maybe to the third decimal place, the same as the theoretical answer. And if you go through all the other possibilities, I think you're going to find it similar. So, for example, how many times did you get 0 hits, Laura?
480.
482. Okay, so it's a little bit further away from the ideal 500 out of 8,000. But again, in terms of a decimal, it's a very, very close approximation. So that was it. If you fill in the rest of the chart. Now, that would basically verify the binomial formula from a practical point of view. The other main formula we learned in the chapter was the E of x, which is, of course, x times p of x. The book has a little thing of I equals 1 to n, referring to the fact that you sum across each of the individual items. You can sometimes leave it out with that to make it a little bit simpler. But if you multiply x times 1 out of 16, 1 times whatever this is, I think it's 4 out of 16, 2 times 6 out of 16, etc., the common sense answer, which by the way we also call mu, the mu should be equal to 2 by a logical, commonsensical, with 2 heads and 2 tails. And we know it's true by the mathematical formula, which you're supposed to verify for the spinner assignment. And finally, you're supposed to actually add up the 8,000 numbers and divide by 8,000 to get the actual average, which I'm hoping Laura did. Did you get to, and what did you get for that? What was the actual average of the sample, which is not the same thing, but should be very similar?
The average was 2.001125.
Okay, you can't get too much better than that, 001. And that's a great verification of the E of x formula, etc. The formula of the chapter was the variance of the random variable, sigma squared, which has this formula, which you were supposed to practice for today's homework. And of course, the related standard deviation of the population of the random variable x, which is equal to the square root of that, which is the same formula but square rooted. And this case came out to, by the shortcut, well, you can do it, I wanted you to do it by the long formula, just to practice for the test, but also by the shortcut formula, which in the case of only the binomial, this is binomial, can be written as n times p times 1 minus p, which is 4 times a half times 1 minus a half, which is equal to 4 times a quarter, which comes out to 1, and the square root of 1 comes out to 1. So the standard deviation and the variance are both theoretically equal to 1, and Laura, I hope you can confirm that. And now the question is, if you took the standard deviation of these 8,000 numbers, maybe you had a list of 3 heads and 2 heads and 2 heads and 4 heads and 2 heads and 0 heads and 1 head and 2 heads and 2 heads. Since 2 comes a lot, 3 and 1 and 2 and 4. Well, you probably get a number that looks something like this if you're doing this randomly. But then the average of those 4,000 numbers should come out to very close to 2. And the standard deviation, if the theory is correct, and it is, of course, not of course, but it is, 1. And Laura, what did you get for the standard deviation?
0.99.
You got 0.99. Okay, good.
Or the standard, yeah, 0.998.
Hey, wow, you're keeping it close. So it's off by 0.002. I think it's a very nice, strong confirmation of all the theory that we're trying to do.